Okay. So good evening everyone. Welcome to Gate Academy Global. So today we are going to discuss about the multiple select questions and the questions which has been added in Gate 21, and that is organized by IIT Bombay. So now I think you all are able to listen me. Okay. So this new question, new type of question that has been added in Gate 21 onwards is multiple select question. So what is multiple select question? Many students were asking about the what is the multiple select question, and they were demanding the in English language. So that is why I came here again, because yesterday only in the Gate Academy main channel I have discussed about the multiple select questions. So today also I will be going to discuss the multiple select question, okay, and how to solve this multiple select question, which kind of questions that can be asked in multiple select question. Okay, so are you all listening here? Okay, so please share this video and press the like button, so that the many people can get benefited when they come later. They can find that video useful. So multiple select questions, as you all know that there is a already one session going on in our main channel, that is Tabartod EMT Abhyas, and in which I am discussing the multiple select questions. So the students who are not able to understand the multiple select question, or if you want to practice the multiple select question, then please visit that Gate Academy main channel, and you can watch those videos of the EMT Abhyas, and you will get some multiple select question based on the plane wave propagation. So today only I discussed the 5 multiple select questions, and so from there you can have some idea how this type of questions can be asked. Okay. So let's find this which kind of question is asked. So let's solve one question, and by that question we will see which type of question is asked in multiple select question. Okay. So are you all ready to solve the multiple select question? And that is based on and yes, this session is useful for all the branches like EE, EC and IN. So all type of students should come and take an advantage of this session. Okay, so this is the question. So this is the question. You can see a thin spherical insulating shell, a thin insulating spherical shell of radius r carries a uniformly distributed charge such that potential at its surface is V naught. Potential at its surface is V naught. A hole with a small area alpha 4 pi r square, where alpha is very less than 1, is made on the shell without affecting the rest of the shell. Which one of the following statement is correct? Which one of the following statement is correct? That we have to see. So the ratio of the potential at the center of the cell, after making that hole, to that of the point at r by 2 from the center towards the hole will be 1 minus alpha upon 1 minus 2 alpha. Option B, the potential at the center of the cell is reduced by alpha V naught. The magnitude of electric field at the center of the shell is reduced by alpha V naught by 2r. The magnitude of electric field at a point located on a line passing through the hole and the shell center on a distance 2r from the center of the spherical shell will be reduced by alpha V naught by 2r. Okay. So this is the question. Please find this question. You can note it down, and then we will start solving the question. Okay. Yes, good evening Payal. Yes, questions will be big, and so the questions will be big in the multiple select question. There is a possibility that you will find the questions lengthy. So please note down this question, and after that I will start discussing the question. So here we are having a thin spherical insulating shell. That means if we charge that spherical shell, the charge will be distributed on the surface of the sphere. The complete charge will be distributed on the surface of the sphere. So what is the surface area of the sphere? So the surface area of the sphere is 4 pi r square. So the total charge Q, if I take the total charge is Q, so that is distributed all over the surface, that is distributed all over the surface 4 pi r square. Okay. Okay, so let's start solving this question. So we are having one sphere like this. Okay. Now the charges are present on the surface of the sphere. This is the center and the radius of this sphere is r. So it is given in the question. Now we are making some hole. So we are making some hole here. Let us say that hole is somewhere here. Suppose we are making an hole here. So let's write the total charge on the surface. So the total charge on the surface is Q. Okay, we are assuming that the total charge on the surface is Q. So in 4 pi r square, the total charge is Q. So in unit area, the total charge will be Q upon 4 pi r square. So this is the total charge that is distributed in the unit area. So what are the charges that has been distributed in this particular part? So what is this area? So the area of this is given as the whole area. This is the whole. Okay, so this is the whole, and the area is given as alpha into 4 pi r square. So whole area is given as alpha into 4 pi r square. So how many charges are present? So alpha 4 pi r square, the charges will be Q upon 4 pi r square into alpha 4 pi r square. So this 4 pi r square will get cancelled, so we will get alpha into Q. So alpha into Q charge will be present in this particular hole. So we can say that the total charge was distributed on the surface is Q, and in that particular charge Q we have subtracted this particular charge Q minus alpha Q. So we can say that this particular complete sphere is having a charge Q. This sphere is having a charge Q, and this particular hole is having a charge alpha Q. So we are saying that we are subtracting the total charge. So the complete charge is Q, and out of Q we are subtracting the minus alpha Q. Okay, so we can say that we are having a sphere of radius r, and it is having a charge Q, and here also we are having a point charge of magnitude minus alpha Q. This is the whole charge. Okay, so this is the charge which is present on that particular hole. So this is the charge present in hole. Okay, so how many charges we have removed? So the number of charges we have removed is minus alpha q. Okay, so minus alpha q charges have been removed and the total charge is q. Now it is given that a thin spherical insulating shell of radius r carries a uniformly distributed charge such that potential at its surface. So potential at its surface is given as V naught. So potential at the surface will be V naught, and V naught is how much? This is K Q divided by R. Okay, so potential on the surface is KQ by R. Okay, is it clear to you? Potential on the surface is given by KQ by R. Now let's discuss about the first option. So this part is clear. Okay, now let's discuss the first option. So the first option is saying that the ratio of the potential at the center of the shell. So what is the potential at this point? Let us say this point is C, because this is the center. So let us say this point is C. So what is the potential at the center? Can anybody tell me? So potential at the center is of a sphere, we know that this is KQ by R, and potential at the center will be potential at the center. Potential at the center will be, this is KQ by R only, that is V naught. Why it is so? Because the electric field inside the sphere is 0. Inside the sphere electric field is 0, and if the electric field is 0, so we know that this E is equal to minus of gradient of V, and to make the electric field 0, the V should be constant. So to make electric field 0, V should be constant. It means that this is going to be a equipotential surface. Okay, so inside this, at all the point the voltage is K naught KQ by R, because on the surface the potential is KQ by R. So inside the sphere also, inside the sphere V will be KQ by R only. Okay, because we have to make an equipotential surface, that is the constant voltage. So if the voltage is constant, then the electric field will be 0. So this is the point. Now we have to calculate the potential at R by 2 from the center towards the hole. So we have to make this line. This is R by 2 distance from the, suppose this point is B. So this is the R by 2 distance towards the hole. So towards the hole, this is at R by 2 distance. So what is the potential at B? So let's find potential at point B. So potential at point B will be K the charge is minus alpha q divided by R by 2. So this is just because of this point charge. So let's find and let's find it here, potential at point B. So at this point B, the potential because of this charge is K minus alpha q divided by R by 2, because it is the distance R by 2 from here also. So this is also the R by 2 distance, this is also R by 2. Okay, and the potential because of the charge distributed on the surface. So how many charges are distributed on the surface? So the charges is Q. So that is K q divided by r, because of this surface, the charge potential at the center will be so the total potential at point B, this will be minus kq by r, we can take common and let's take the only plus sign. So we will get here kq by r, so this is minus 2 alpha and plus 1. So kq by r is denoted by V naught, so this is V naught 1 minus 2 alpha. So this is the potential at point B. Similarly, there is one point which we have missed is, see, the potential at the center. Potential at the center, because of the charges that is present on the surface, is, we have written this kq by r, but there is one more potential that will be existing on the center, is that is nothing but minus alpha q k divided by r only, because of this point charge, this charge which is having a minus sign, this charge that has been removed, the charge that has been removed, it is also having the distance r from the center. So we are calculating the potential at the center. So the potential at the center, because of the two things. First, that is the complete charge that is distributed on the surface, and there is a one more point charge that has been removed, that we have represented by minus alpha q, that is the charge that has been removed. So because we have removed it, we can subtract that value, or we can say that there is a negative point charge. So the negative point charge minus alpha q is present at that particular point. So we are having kq by r, if I take common, so we will get V naught 1 minus alpha. So we missed that particular part. Now tell me whether this part is complete or not. Now tell me whether this part is clear or not. See, first of all, when we are not making that hole, the total charge was q on the surface, and when we make a hole, then how much charge we have removed? So the total charge was q, and the charge that has been removed is represented by a negative charge of minus alpha q, because ultimately when you remove, how much charge will be present there? So that particular part we have subtracted out of the total charge q, we have subtracted the minus alpha q. Yes, Vishwanathan, the total effective charge will be q1 minus alpha. Yes, q1 minus alpha will be there if you remove that particular charge, or when you make an hole, the total charge will be q1 minus alpha. So what we are doing is, we are calculating the potential because of the sphere, and we are considering that hole as a point charge. Why we are considering that? Because the hole is very small, and when the hole area is very small, it can be considered as a point charge. But to make the overall effect, we are removing that particular charge. So because the charge should be subtracted, so we are subtracting the charge. How we are subtracting? We are considering that particular charge with the negative polarity. So with the negative polarity, we have actually reducing that particular effect of charge. So if you calculate the ratio Vc upon Vb, we have to calculate the ratio of point at the center and at distance r by 2. So at the center we are having V naught 1 minus alpha, and at point B we are having 1 minus 2 alpha. So this V naught will get cancelled, and we will get 1 minus alpha divided by 1 minus 2 alpha. So this is the actual potential, the ratio of the potential at two different points. One is at the center and another is at distance B by 2. So we are having this particular part correct. So Y for alpha q distance is r by 2. we have to calculate this particular part. We have to calculate at any distance r by 2, right? Because this is the point charge, this is the point charge, so because of this point charge we are calculating the potential at this point. And we have already considered that because of the sphere that is distributed, because of the charge that has been uniformly distributed on the sphere, the potential should be constant at every point. So when we are talking about this particular charge q, we are taking the potential kq by r, because we have to make the equipotential surface. But when we are considering this particular point charge, a simple absolute potential because of a point charge is given by kq by r. So the k and the q is the minus alpha q, and the distance is r by 2 here. Vishwanathan, I hope now it is clear to you. Okay, there are two different charges we are considering. One is a spherical charge that is distributed on the surface of the sphere, and another is the point charge. So because of the charges that is distributed on the sphere, the potential is constant, and because of the point charge, the potential is calculated. Okay, so now you have got this one. Now the second one is the potential at the center is reduced by alpha V naught. We are saying that the potential, see this is the question, the potential at the center of the cell is reduced by alpha V naught. So potential we have calculated, and we are saying that the potential at the center. So potential at the center, we can see that it is written as V naught minus V naught into alpha. Okay, so V naught minus V naught of V naught alpha. So what is the potential at the center? That was V naught, and it is reduced by, because there is a minus sign, so we are saying that it is reduced. Okay, so this is reduced by V naught alpha. Clear? Reduced by V naught alpha. So according to the option, if you will go here, this is the given here. Here you can see the potential at the center is reduced by V naught. So option A is correct, option B is correct. So the two options already corrected. Now we have to see whether the option C or D is correct or not. Yes, B is also correct and A is also correct. So A and B both are correct. Now let's talk about option C. So in option C, the magnitude of electric field at the center of the shell is reduced by alpha V naught divided by 2r. Since this is the sphere and this is the distance r, the total charge is q. Okay, so electric field at the center is 0 because the charges are distributed on the surface. So the electric field is 0. Okay, so this is the whole. So the charges here we have written is minus alpha q. Ashok, in the question it has been mentioned, please check the option A, that is given that at r by 2 distance from the center. I will show the option to you. Okay Ashok, wait for a few minutes, I will tell you the option. Electric field at the center is 0, and because of this negative charge, the electric field will be at the center of the shell, at the center of the shell is 0, because of this center is 0, and the other charge is this minus alpha q and into k q by r, how much? The distance is r whole square. So now this is minus alpha q k divided by r square overall, and alpha ये आ जाएगा, this one will be minus alpha v naught upon r, minus alpha v naught by r. So if I take the magnitude, so magnitude of electric field, so magnitude of electric field is alpha v naught by r, alpha v naught by r. So what you are observing is, when there is a complete sphere which is having the charge q, the electric field at the center was 0. So electric field at the center was 0 when there is no hole. Okay. So when we make a hole, we are removing some charge. So that portion of charge we are considering with the sign minus alpha q. So because of the charge distributed on the sphere, the electric field at the center is 0, and there is another point charge we have considered, that is minus alpha q. So because of this minus alpha q, the electric field at the center will be minus k q by r square, the distance. So that is minus alpha v naught by r, and in the option if you will see, it is written that magnitude of electric field at the center, magnitude of the electric field at the center. So how much we get? You can see the magnitude of electric field at the center of the shell is reduced by alpha v naught by 2r. Here it is written that 2r, but we are getting alpha v naught by r. And if we say about the magnitude, previously when there was a no hole, the electric field was 0, but when we substitute that point charge in place of hole, we are getting some amount of electric field, that is minus alpha v naught by r. So the first thing is, that is not reducing, magnitude is somewhat increasing if we talk about magnitude, because in the option it is given that the magnitude, so magnitude of electric field is not reducing, it is increasing, because previously it was 0, now it is having alpha v naught by r. We are talking about the magnitude. Don't consider that minus sign. Why we are not considering the minus sign? Because it has been already written here the magnitude. So the magnitude is actually increasing, because it was 0, now we are having alpha v naught by r, but here in the option it is given that alpha v naught by 2r. So because of that, this option is incorrect, and it is also written reduced, but their electric field there is increasing. So that is why this option is incorrect. So this option C is incorrect because of the two reasons. First is the electric field at the center is not reducing, it is increasing, and the second one is the value by which it is increasing is alpha v naught by r, not alpha v naught by 2r. So Ashok, your question was, here you can see that the r by 2 distance from the center, so that is why we have calculated r by 2 distance. Okay, so you can see from here. Thank you, Rohit. Now coming to this fourth point, the magnitude of electric field at a point located on the line passing through the hole and the shell center and the hole, the line passing through the shell center to the hole on a distance of 2r from the center of the sphere will be reduced by alpha v naught by 2r. Okay, so let's solve this. So we are saying that at any distance point P, suppose the complete distance is 2r, the complete distance is 2r. So we are saying that at this point the electric field is reduced by alpha V naught by 2r. So let's find the electric field at point P. You can see that this point P we have drawn is, it is passing through the center of the shell and it is also passing through the hole. So this is the hole we are considering. So this is the hole and the line is passing through the hole and the center of the shell. So electric field at point P is again because of the two charge. One charge distribution is on the sphere and other charge that is removed because of the hole. So the electric field at point P is because of the spherical charge, it is K Q by R. R means the distance is 2r. We know that the electric field because of any point charge is given by KQ by R square. So the charge distributed on the sphere is Q. So at any distance outside the sphere, the electric field is just like a electric field because of a point charge. So because of this charge, the electric field is given by KQ by R square, but the distance is distance between the point P and the center is 2r. So that is KQ by 2r square minus K times of the charge is, if you write plus sign actually, so because the charge is minus alpha q, so this is minus alpha q, and how much distance it is having? So the distance from this hole to this point P is r. So now we are having KQ by 4r square minus alpha KQ by r square, and if I take this KQ by r common, okay, so let it be like that only. If I write like this, see this KQ by r square minus alpha K alpha Q, this alpha Q divided by r is represented by V naught. So this is minus V naught Q by r. So minus V naught Q by r, okay, sorry, this one is alpha. K Q by r is given by V naught, so minus alpha V naught by r, it will be minus alpha V naught by r. So now we can say that here this is the electric field due to spherical charge, due to charge on sphere, and because of that particular hole, because of this particular hole, this electric field is reduced by this value. It is reducing by this value minus V naught alpha by r. It is reducing by the value minus V naught alpha by r. Now what is the option? If you will see, the option is alpha V naught by 2r. Again it is written that alpha V naught by 2r, but here we are having alpha V naught by r. So option D is also incorrect. Option D will also be incorrect, because here it is written that this is alpha V naught divided by 2r, but actually it is reducing by alpha V naught by r. Okay, so this type of question can be framed for multiple select question. Okay, so this is the one of the question that can be asked in GATE, in EMT. So we were discussing about the EMT subject. Okay, so the correct answer will be option A and option B. I hope it is clear to you. So I think everybody has got the meaning of multiple select question, right? Everybody has got the meaning of multiple select question. Yes. So we are going to start a crash course on communication system, and the day will be announced tomorrow, and tomorrow there will be a announcement video for you, in which what are the things that will be covered in that particular crash course will be discussed. Okay, so watch that particular video. That is not live. We are considering that recorded video I am uploading. Okay, so most probably it will be announced. It will be starting within a 2 to 3 days. 2 to 3 days it will be starting, and only the important things will be covered, not the complete syllabus will be covered, only important topics and few questions will be covered. So every detail about that crash course will be given to you tomorrow in the evening. So please watch that video and share that video so that many students can come. Okay, so this is the multiple select question. So everybody has got that value, A and B, yes. So I think now everybody has got that what is the multiple select question. So now there is no need to discuss about the multiple select questions separately. In our communication course itself, we will frame some question from the multiple select questions, and that will be solved in the crash course only. Okay, so separately I will not take any session on MSQ again, because through this particular session I wanted to tell you about the which kind of question can be asked in MSQ. Now there are three particular section, that is numerical answer type, and second is multiple choice question, and third one is multiple select questions. So in this way now the GATE 21 will be coming, the paper will be coming in this three section, and 1 marks and 2 marks, and there will be no partial marking. So if you find any one of this correct, so you will not get any mark for that. If you solve the question and if you mark both the option, then only both are correct. If there are two options that are correct, if you mark both the option correct, then only you will get the marks. If you suppose mark option A only and B, C, D, if you leave it, then you will not get any mark. Like JE we will get some mark if even if we answer the partial correct one. Partial answer if correct, then only we get some marks, but in GATE there will be no partial marking. I think it is also clear to you. Ashok, we will take some session on communication only. So after the communication will be completed, then only we will start the EMT session again in the global channel. There is no negative marking. Yes, Payal, there is no negative marking in MSQ type question. So remember that there is no negative marking, there is no partial marking. So if you solve the question correctly and mark all the options, those are correct, then only you will get full marks, else you will not get any mark and not negative marking. Random process will also be covered. So all the detail, Ashok, you will get in the tomorrow video. So please watch that video and share with your friends. In main channel EMT will be continuing. In main channel EMT will be there. In main channel the session of this EMT Abhyas will be continuously going around 1 month, because until I finish the complete syllabus of EMT, I will not stop that session. Okay. Okay, so this is all about this today's session, and the aim was only to tell you about the MSQ. Okay, and so please watch that video in the for more MSQ type question. Please watch the Tabartod EMT Abhyas session. You will get many questions of MSQ daily on that particular session. So I will not be taking the session separately for MSQ. The Tabartod EMT Abhyas will be covering all the type of question that can be asked in GATE 21. Okay. Yes, 500 plus questions are awesome. Thank you, Yogita. So we have already done around 50 questions, and we have to solve or more 400 questions around. Yes. Thank you, Yogita. Most welcome. Okay, so let's finish today's session, and we will be discussing more about the upcoming session in the next live. Okay, yes. Thank you, and I love you all. Thank you, Ashok.